Welcome back to section 2.4. We're going to continue with problem number 15. We're going to get rid of I in the denominator. To do that, because we have two terms, we're going to multiply by the complex conjugate, which is 4 minus 5I in the numerator and denominator. We're just really multiplying by 1, which is why we're not changing the value and why it's allowed. So we distribute, we get 8 minus 10I. And in the denominator, because we're multiplying conjugate, it's going to be A squared minus B squared. So it's going to be 16 minus 25I squared. So in the numerator, we have 8 minus 10I over 16 minus 25 times negative 1. So it's 8 minus 10I all divided by 16 plus 25, which is 41. So to finish up, we're going to split them up. 8 over 41 minus 10I, or 10 over 41I. And there is our answer. Now, problem number 17 is more complicated. So what we're going to do is we're going to treat them as two separate problems and then add them up at the end. So what I'm going to do, I'm going to get rid of I in the first fraction by multiplying by the complex conjugate 1 plus I over 1 plus I. So we get, distribute the 3 plus 3I over 1 plus I times 1 minus I is going to be 1 squared, which is 1 minus I squared. So we have 3 plus 3I over 1 minus negative 1. That's 3 plus 3I over 2. Now the second fraction, I'm going to multiply by 1 minus I over 1 minus I. So I end up with 2 minus 2I over 1 minus I squared. So 2 minus 2I over 1 minus negative 1. So it's 2 minus 2I over 2. So now we got rid of I in the denominator, which we ended up with a common denominator at the same time. So we can add the two fractions. 3 plus 3I plus 2 minus 2I, all divided by 2. So when we combine in the numerator, 3 plus 2 is 5. 3I minus 2I is plus I over 2. And then to finish up, 5 over 2 plus 1/2 I. And there is our final answer. So with that, when I'm adding or subtracting, I get rid of the I in the denominators first. And then I get a common denominator if I don't have one already. So then you add them or subtract them. Next problem, we're just going to continue cleaning these up. So you'll often see these written. Now, we have the product property. Let's look at some examples. I think that'll just make it more sense. The product property, the square root of A times B. We can split them up as the square root of A times the square root of B, and we can also put them back together. So what I would do for problem number 18 is I would put them back together first. So it's going to be the square root of negative 3 times negative 12, which is the square root of 36. So after all that, we end up with just 6. So there's using that product property to put them back together. On the next page, we're subtracting these. So what we're going to do is we're going to clean this up. We can't combine them because they don't have the same radicand. There's not the same number underneath the radical. But the square root of 48, negative 48, it's the square root of negative 1, the square root of 16, and the square root of 3, minus, now the square root of negative 27 is the square root of negative 1, the square root of 9, and the square root of 3. So we're going to get I times 4 times the square root of 3, or we can look at that as 4I squared of 3, minus I times 3 times the square root of 3, which would be minus 3I times the square root of 3. Now they're like radicals. We have 4I root 3 minus 3I root 3. That just leaves us 1I root 3, or I, times the square root of 3. Now, this book likes to write it like this, the square root of 3 times I. I like writing I in front of the radical. I just think it looks nicer, but you might see it written as the square root of 3 times I. It's the same thing. Order doesn't matter for multiplication, but I just feel like the I can sometimes look like it's under the radical in the other way. Next one's a little bit trickier. What I would do is I'd clean up this first. The square root of negative 3. So what we could do is we can write this as negative 1 plus, and the square root of negative 3 is I square root of 3 squared. You can write it out the long way if you want to. Negative 1 plus I root 3, negative 1 plus I root 3. This one, it might be a little bit easier to write out the long way. So when you multiply them, you get negative 1 times negative 1 is 1, minus I root 3. I root 3 times negative 1 is minus I root 3. I root 3 times I root 3. So what you're doing is you're squaring the I. So you get plus I squared times, and the square root of 3 times the square root of 3 is 3. So it's 1. Negative I root 3 plus negative I root 3 is negative 2I root 3. And then it's going to be I squared is negative 1, so plus negative 1 times 3. So that's negative 3. 1 minus 3 is negative 2 minus 2I root 3. Like I said, the book might write it like this. Negative 2 minus 2 root 3 I. It's another way to write the same exact answer. Next, we're going to be solving the next few problems. For number 21, because we have x squared and a constant, what we can do is we can isolate the x squared. So x squared equals negative 4 by subtracting 4 from both sides. Take the square root of both sides. X equals plus or minus. Now the square root of negative 4 is 2I. So plus or minus 2I. There is our answer. For number 23, I'm looking at it and I know I can't factor it. You can always check to see if it's factorable if b squared minus 4ac. Negative 2 squared minus 4 times 3 times 5. 4 minus 60 is negative 56. It's not a perfect square and it's negative, which tells us we're going to have an imaginary solution. So we have to use the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. And I wouldn't use completing the square for this because my leading coefficient is 3 and it's not going to divide evenly. It's going to end up with a lot of fractions. Too much work. X equals, b is negative 2, so the opposite is 2, plus or minus the square root. Now I just found b squared minus 4ac is negative 56. I'm going to use that. All over 2 times 3. 2 plus or minus something divided by 6. Now the square root of negative 56. That's the square root of negative 1, the square root of 4, and the square root of 14. So with all that, we end up with 2I square root of 14. So x equals, now split them up, 2 over 6 plus or minus 2I square root of 14 over 6, and reduce the fractions, x equals 1/3 plus or minus 2 over 6, that's going to be I square root of 14 over 6. Like I said, the book might write it like this, 1/3 plus or minus the square root of 14 over, that's a 3, excuse me, 3I. Same thing, just a little bit different format. I'm going to check to see if number 23 is factorable. B squared minus 4ac, 16 squared minus 4 times 17. Here's where the calculator comes in handy, especially for bigger numbers. And you're going to get a discriminant of negative 16. Not a perfect square, and it's negative. So now we have to use the quadratic formula. X equals, once again, I wouldn't use completing the square just because of the fraction. with the leading coefficient being a 4. The opposite of b, plus or minus the square root. B squared minus 4ac, all divided by 2a. So it's going to be negative 16 plus or minus the square root. Now I found b squared minus 4ac is negative 16, all divided by 2 times 4. Negative 16 plus or minus, now the square root of negative 16, that's 4i over 8. Split them up, negative 16 over 8 plus or minus 4i over 8. So we end up with x equals negative 2 plus or minus 1/2 I. So it worked out to be not so bad. And then finally, problem number 24. B squared minus 4ac, just to make sure I can't factor it. 14 squared minus 4 times 8 times 9. So after all that, you get a discriminant of negative 92. X equals the opposite of b plus or minus the square root. B squared minus 4ac, all divided by 2a. Negative 14 plus or minus, I already found it. It's negative 92 underneath the square root over 2 times 8. Negative 14 plus or minus something over 16. Now, the square root of negative 92, square root of negative 1, and the square root of 4, square root of 23. So after all that, it's 2i square root of 23. So negative 14 over 16 plus or minus 2i root 23 over 16. So x equals negative 7/8 plus or minus I square root of 23 over 8. You might also see it written this way, negative 7/8 plus or minus the square root of 23 over 8i, where I is at the end. Okay, keep in mind I is the square root of negative 1, allows us to take the square root of a negative, and I squared equals negative 1. Thank you, and I'll see you in the next.